just I will hand over to Mr. Naeem and request him kindly follow the timeline because it's already we are going some late. So 15 minutes and we want to listen from you. Thank you.
Let me share my screen and I can go with it. Can you hear my voice?
Yes, sir.
Can I start now?
Yes, sir, sure.
Alright, I cannot see basically a lot of you. Assalamu alaikum and good morning still for Pakistan time. Naeem Siddiqui. I was working in Siemens Pakistan before. Now for the last 20 years I'm in USA. Very delighted to basically talking to you guys and thank you Dr. Pali and Pakistan technology first off how you can reduce the carbon footprint in the transmission efforts by reducing the SF6 equipment. So this technology you can see on title screen, blue clean air vacuum switchgear is the Siemens energy technology. So some background is from decarbonization and greenhouse gas emission point of view. When started in 2015, Paris Agreement, where 189 countries basically just signed up to take the actions again in decarbonization and greenhouse gas emissions. Aligned with this agreement, the three major regions, United States, European Union and China, they have set out their goals for clean energy, clean electricity and net zero greenhouse gas emissions. So you can see basically in dark color three regions. I left my Pakistan like this. I hope basically we may have one day Pakistan goals for climate change as well. Two large states, California state and New York state, they already worked out how to ban SF6 gas, which is one of the important gas in transmission efforts and switchgears, you know that. And also European Union also they have approved basically the ban on all kind of F gases actually. So these are basically going on in US and European regions. When it comes to basically Pakistan's situation is not different from all these developed countries. Also maybe a little bit worse because Pakistan is doing a very low in climate policy. And all these basically, I don't want to read the line items, but very shortly, it's a call for reaction to check all possible causes to reduce greenhouse emission in Pakistan as well. So that is why basically, this topic is very important that at the same time when North American region, US and Canada and also Europe is evolving basically with some technologies which is SF6 free. So Pakistan needs to know these technologies so that in future we can have basically these technologies implementing in Pakistan as well. So let's basically see a typical substation layout. We have several equipments there, one end to end, but we have lifetime circuit breaker, sometimes dead tank circuit breaker, and GIS system. Every one of these switchgears, AIS or GIS, they are using SF6 gas as of today, and that is the biggest challenge for utilities because they have a large gas equipment footprint with SF6. As you know, basically SF6 equivalency of CO2 emission almost basically 24,300. So it's a very big number, and most basically an important part is this is busy slide. The slide will be available to you, but most important part here is this equivalency of 24,300 of SF6 gas is still basically in an atmosphere in 3,200 years, and it does not basically even absorb in normal basically in atmosphere. So you can see equivalency of number of trees and number of cars basically, and if leakages is there, an ideal leakage rate of 0.46%. They still have a lot of basically equivalency with trees and cars. And in Pakistan, if you assume that you have 10,000 basically light circuit breakers in your network, either at Wata or electric or anywhere else, that equivalency is also basically about 2 million cars. That's a historical risk. You can imagine Pakistan basically we have in terms of SF6 gas in our switchgears. So these are the different equipments. I'm basically mainly focusing on circuit breaker, high voltage circuit breaker, either it is light tank, candlestick type, or high voltage or extra high voltage or dead tank. Any kind of circuit breaker and high voltage transmission systems, basically you can imagine they are using SF6 gas as an insulation medium. So 10, 15 years back, this discussion has started, and what's in market was like we have on the left side you can see SF6 gas, and in the middle basically two C4 and C5 insulation gases. These are 3M manufacturer who is the producer of these insulation gases, and more or less C5 somebody is using it, but C4, which is fluoronitrile, is still in use as a mixture to use as an insulation gas. But whereas basically clean air is the Siemens energy technology, and not only Siemens energy but also other manufacturers also basically working with using clean air as insulation medium as well. So mainly basically we have fluoronitrile mixture an option, and also clean air as an option also. And you can see basically some plus and minuses with red color and green color. These are the advantages and disadvantages using basically the gas mixtures for insulation medium. So this is basically a generic name of 3M Novak for those insulation gases. But like I said, these are also in list of PFAS substances. PFAS substances are polyfluoroalkyl substances which are manufactured chemicals. And a lot of basically in states and US, they are making a ban on these PFAS substances, and these two insulation gases, they are part of that list. So honestly speaking, the only ultimate and sustainable choice is left with clean air using as insulation medium. So evolving basically product evaluation criteria for switchgear product is, you can see basically has been changed in the last 5 years in different basically regions. And environmental impact is the number one, health and safety, performance, gas handling, and manufacturer competence. These are the criteria based on that. Different switchgear equipment customers and utilities they are selecting. So if you look at clean air from advantages point of view, this is the most basically known gas. We are breathing in it every day, every minute, every second. I don't want to basically again read each and everything line by line, but has a lot of basically advantages if you are using clean air instead of SF6. On the other side, in breaker basically the function of the breaker is breaking the current in case of any fault on your transmission line. So this interruption or current interruption is going on in vacuum bottle, which is basically completely sealed bottle with some contacts in it, and it has a lot of advantages as well. Not everywhere in Pakistan, for example, but if you think about your northern areas where sometimes the temperature is very, very low, so vacuum basically interruption technology also can work at up to minus 50 degrees centigrade as well. So it has basically a lot of advantages. So Siemens technology, which is blue, is the combination of using clean air for insulation, and current interruption is going on in vacuum bottles. So combination of these two things, we call it basically game-changing blue technology for switchgear, not only circuit breaker but also GIS systems as well. So very overall, basically, picture of the construction of the breaker. On the left side, you see basically lifetime breaker, which is the most of the time Pakistan is using basically these lifetime breakers. On the right side, you can see dead tank circuit breaker. So if you see the dissect view of right side, which is the SF6, which has basically the mechanical interrupter, and also this mechanical interrupter is replaced by the vacuum bottle. You can see here, and then filled with the clean air. That's all has changed, and this change can give you a lot of operational advantages, a lot of basically environmental advantages, and this is another view of the detail inside of the inside of the interrupter unit. On the right side, you can see the SF6, where we have basically a very complex contact systems, main contact and the pin contact, and at the time of current breaking, you have very long arc, very long basically arc energy, we call it arc energy in terms of basically breaking the current at 40 kA or 63 kA, very high heat basically source that can produce inside of the breaker. Whereas in vacuum tube, you can see on the left side that we have very small distance, and it's kind of like a snap action. It can basically make or break type thing. So this is the history of the vacuum tubes. We have basically a long history of producing it also. Some basically in more detail how to produce 72 kV or 135 kV. In Pakistan, 132 kV is the most common standard. So this is the way the construction of these vacuum tubes are. This is inside of the contact system in the vacuum tube. You can see basically a special contact system. You can see on the screen that on the right side, this is the specialized contact. Siemens designed for vacuum bottles for high voltage circuit breaker and GIS system, whereas left side is the pinch effect, which is going on right now. Okay, this is the arc energy I was talking about. If your breaker is oil breaker or your breaker is SF6 breaker or vacuum breaker, arc energy is very, very low on the vacuum system, and that is why basically the life of the contacts inside of the vacuum for current interruption is very, very high. So normal SF6 breaker life is 25 to 30 years. Vacuum clean air breaker could be easily, you can say 50 to 60 years, so almost 2 times the life of the breaker you can have. There are basically several tools globally available which can calculate the total ownership cost comparison between SF6 breaker and vacuum clean air breaker. On this page, basically on the bottom left, you can see one EPA US agency. They have basically a calculator on their website. You can download simple Excel sheet. You can put in basically some parameters of your utility or company, and you can see basically if you have 10 breakers or 50 breakers, you can calculate overall basically comparison of the ownership cost between these two technologies. So this is kind of like a roadmap from Siemens Energy. You don't need to read it again, but we have the commitment, and we have basically and all the factories very committed to supply basically this technology globally to each and every country. If you have basically a pilot project for 132 kV, you should be basically asking any Siemens energy representative. They will be glad to basically introduce you with this product. So we're going to start with the pilot. With that, basically, this is all. Unfortunately, time is very short. I can take one or two questions if you have one. Otherwise, on this screen, you can see my email address, my phone number also. We'll be glad to basically answer any question you may have. Hopefully, more detailed presentation organizers basically providing to you in terms of basically magazine or something. But again, I can take basically some question if you may have.
Thank you, Naeem sir, for a wonderful presentation. So, as Naeem sir have joined online, so we will take question for this presentation particularly at this time.
What do you?
Yeah. So, can you please move the mic to Irfan sir?
I see one hand.
Yeah.
Yes. Naeem Irfan here, your old colleague, Irfan Ahmed.
Unfortunately, I cannot hear Nishan. If you can help me
And
to.
here, is it better now? Can you hear me now? Hello? No, I think I...
Can you guys hear me?
Yeah, we can.
Hello? Can you hear me now? Hello?
I can hear you now.
Okay, that's fine. So one question. You are into switchgears. Have you ever thought, or Siemens thought about solid state high voltage switchgear? Solid
Say one more time, please. I do not think basically Siemens ever being basically in solid state. Switch gear for high voltage at least. No. The answer is no. Yes.
Okay. Thanks.
So, thank you very much, Naeem sir, for very good presentation. I think we need some push from regulator and even the agencies that are making the specifications for switchgears, either NTDC or K Electric. So in future, we should shift from SF6 to other non-greenhouse gases. That is very important as climate change is impacting Pakistan very harshly.